thanks for coming, everyone. I'm just going to kind of kick this meeting off and go over a brief introduction of what we're hoping to accomplish here today. A brief overview of the DER grant that we secured and we're going to work with all you guys on, and then we'll kind of turn it over to you guys for introductions, turn it over to Nimish to give a demo of his software, and then open it up for questions here at the end. I'm Bryce DeBork from Michaels Energy, for those of you I haven't met yet. We're working with Gilbert Mechanical and the Minnesota Department of Energy Resources on a grant here for continuous commissioning of outpatient medical centers. If you want to flip it to the next slide, Chris.
Yeah, I'm that guy.
There you go. Okay, so we're kind of looking at a two-pronged approach here. We're going to look at outpatient clinics that contain surgery centers and some that do not contain surgery centers. I don't know if we have everyone in the room or phone here who's part of our free surgery center pilot now.
Yeah, no, both have clinics without no surgery center.
Okay. Anyway, so what you can see here is kind of a matrix of what we're hoping to accomplish. I'll go over kind of the bread and butter here on this side first, is the clinics with surgical centers. What we're hoping to do is install an Allerton dashboard system so we can continuously monitor energy usage in those systems. That would be natural gas and electricity. And how we're going to do that, I mean, I think that we're going to be open to some suggestions. I mean, one of the goals we really have is to figure out how to format this system so it best serves you as medical clinics. So we're planning on doing that with 3 facilities. We're going to do some benchmarking with Portfolio Manager, which is Energy Star, maybe other benchmarking tools, and conduct a retro commissioning study so we can follow, projects that have been implemented. Use this software to verify savings, and continuously look at maybe changing some operation and maintenance procedures, see how that affects energy usage. Really, we're just hoping to kind of loop back and connect the dots. Right now with your typical energy bills, you may get feedback, on a monthly basis, and there's typically a couple week lag even after the month. So with this system, we're looking at 15-minute interval data, maybe even less, depending on what we deem appropriate. So there's going to be that real-time feedback, so you can see, hey, my energy use spiked up in the past day or two. What's going on? Maybe you can track a rooftop unit that's faulty or something along those lines. So we can talk about that a little bit more as well. But that's really the meat and potatoes of what we're hoping to do there. So as I said, we're going to implement the dashboard in 3 facilities, and then probably do a detailed recommissioning study in 2 other facilities just to kind of get a overall or better picture of what the outpatient surgical centers look like in Minnesota. On the flip side, we're going to look at least 5 clinics without surgery centers. And there what we're doing is partnering with Lawrence Berkeley National Labs, who's one of the Department of Energy's large research arms. And they've developed a process to kind of do a high-level continuous commissioning of different commercial types of buildings. They haven't really expanded it to healthcare yet, and that's one of the things that we're looking at doing here, is seeing how well this works in a clinic-type setting, and maybe offer some feedback to them. Again, we're going to look at benchmarking these buildings using Energy Star Portfolio Manager. We're going to also follow that up with a more traditional kind of energy, half-day to full-day energy assessment after this, Lawrence Berkeley method is used, and we're going to see how well those match up to each other. Are things getting missed in these high 1-hour contractor-led walkthroughs, or are they catching 90+% of that? That's what we're here to find out. That process is going to be repeated every 6 months according to the Lawrence Berkeley framework, and it's another method of keeping on top of things and seeing how we can change energy usage in the facilities. I think, am I missing anything there, Val? I think that's...
No, I think pretty much covered it. I have talked to most of them, so...
Okay.
I think only thing is we are working with Centerpoint and Excel to provide the pulse signal, and I think they have made a request for 2 sites already. I think one Chris has made and another is Fairview has made, I think. And third site is the one where I will need your help to address through for regional ICAP.
All right. Go to the next slide, please. So this is kind of an overall projected impact we're looking at in the state. As a lot of you guys in the room probably know, these outpatient surgical centers and clinics are a rapidly growing market in Minnesota and really across the country as more and more services are getting streamlined and maybe brought out of the hospitals. These buildings are expanding. So what you'll see here is we kind of put together different savings percentages we think we may be able to achieve in these buildings. And there's some backing data on that we'll get into here. And then just kind of what we think are the number of clinics that we could reach in the state if we roll this out on a mass scale. Here the energy units are in million BTUs, which probably doesn't mean a whole lot if you're used to working in kilowatt hours and therms, but needless to say, this 20% range is something we really feel we can hit in a lot of instances. If you go to the next slide, Chris, I can show you some results from previous projects that we've done here. What you'll see here is kind of 2 clinics and 2 outpatient surgical centers, and their baseline usage in natural gas and electricity, total energy use, and then savings that were either achieved and verified via bills, or they've been calculated and implementation's kind of still in progress. So as you can see, overall savings were this 10 to 20 to 30% range is really something that we've achieved in the past and is pretty typical in the healthcare sector from Michael's and Gilbert's experience. So we feel there's a lot of potential out there, and we're pretty excited to work with you guys and see where this goes.
Bob already has a surgical center which we did, and that's on Excel website too. So
oh, great
project.
One of the case studies?
It's a case study, yeah. Very first one.
All right. You can go to the next slide, Chris. So here you'll see kind of the first 3 demonstration sites we have lined up for the dashboard software, unless any of this has changed, but is this still accurate?
Oh, this is.
Okay. We're looking at working with Park Nicollet Ambulatory Surgery, Fairview, Columbia Heights, and then the Hutchinson Eye Clinic here. And we have a list of some expected measures already worked up here. A lot of what we expect to see in this sector is reductions in runtime and alterations to controls in the surgical centers. Right now, the Department of Health has some pretty strict regulations in maintaining pressures and set points in surgical centers, which we want, or we're going to maintain, but there's some opportunity for setting back and still maintaining those relationships while achieving energy savings. And that's where a lot of the savings from these previous, the examples on the previous slide came from. I don't know if we need to go into much more detail here, but I think you can get a copy of all this, you guys. I think there's some more meat and potatoes we'd like to get in Nimesh as opposed to going over this stuff. So,
guys, just for information, Bob Taylor is there from Minnesota Department of Health, whose approval is needed, because originally we worked with Jim Loveland, who has retired now. So
okay.
He is going to help us in that respect with
Great.
Another surgical center for you too.
Well, yeah, we're looking forward to working with you, Bob, and really what we're hoping to do is maybe get a streamlined process for approving some of these changes to surgical center controls. So, we're hoping we can collaborate here between the Department of Energy and the Department of Health and see what we can make happen. You can go to the next slide, Chris. So this is kind of an estimated timeline of our project. This is subject to change, of course, based on how things roll out. But we're hoping to kind of get started after the first of the year on this project, and you know, in the first quarter, really kick off the LBNL process and auditing these clinics and surgical centers. Some of that's going to stretch through the summer more than likely, and work with implementing projects here into the fall and see where things come. I mean, we're looking at probably first to second quarter next year before we have a final report put together. But as you guys know, we're going to have to work with budget cycles in any of your clinics to get projects implemented and really get the results back from the data logging we're doing. So, I don't know. Are there any questions on this? Otherwise, I can turn it over to. It's next on the list. We're going to do introductions. Were you going to lead that, Val, or?
You can lead it as long as you are there.
Okay, I'm up here already, I guess. So, why don't we go around the room again? From Michael's, I'm here, and Nancy Kelly's also in the audience. We're going to kind of be leading the card grant from our end. And Gilbert, do you guys want to introduce yourself?
I think John, you may want to.
I'm John Gorman from Gilbert. I've been involved in the design build of a lot of surgery centers, and it's Val who's kind of led the initiative to get more energy conscience on all this stuff. And yeah, we definitely work with the health department to try to get modifications and run times once they're agreed to by doctor groups and the health department. And yeah, just here to kind of participate and see what the dashboard information is all about too.
Thanks, John.
I'm Bob Daler of the Minnesota Department of Health. That's about it.
Well, myself, I'm Nimish. I come from Allerton, and today I'm going to talk about the energy dashboard. So that's my objective here.
Chris Liebman, Park Nicollet. Welcome, everyone. I'm operations manager for engineering and maintenance for Methodist, our flagship, as well as, let's say 40-ish other properties around the system, Park Nicollet system.
I'm Eric Matheson with Gilbert Mechanical. Be working, helping implement, putting in the allergen and the dashboards. Next.
Well, Munchi, I think most of them I have talked to, so.
Nancy Kelly.
Dave Deschler with Gilbert Mechanical. Looking forward to actually with the dashboard to take it to the next level of what we've done currently and see that real-time commissioning and instant feedback of what systems are doing.
Mark Garfile with the Division of Energy Resources with the state, so I'll be working with Michaels and Gilbert on this project.
Bob Johnson, North Memorial Healthcare, and thank you for the invitation. Glad to put this together. It sounds interesting.
I'm Andy Baumtrot with North Memorial Engineering.
Matt didn't comment on my English here. That's okay.
I didn't catch his first name. What's your first
My
name?
first name is Nimish.
Nimish. All right. Sorry, Bill.
Matt Stedding from Atlanta Health. Eric Johansson, I'm an energy efficiency engineer with CenterPoint.
Kim Macrath from Regional Eye Surgery Center. I'm the clinical director there.
Dave Sale, I'm our driver.
He works with me. He's going to be helping me put this all together.
And who do we have on the phone?
This is Tom Wilkening, Director of Facilities, Review Medical Center.
And is Jim there?
Yeah, you have James Flint and Lonnie Berg with Fairview Facilities.
Okay. Well, thanks everyone for attending. Thanks to Chris for hosting us here, and thanks for everyone else who can make it. I know a little early winter snap here, but I think overall, are there any questions about the process here before we really get into talking about the dashboard and where that's going to go? I know from my perspective at Michael's, we're excited to work with you guys to see what we can find out there. I know some of the clinic properties are maybe not as well maintained as the hospitals, and that's just due to limited staff and budgets, and we all understand how that goes. So, I think this is an exciting opportunity to see what this market segment really offers. We're excited to work with the Department of Energy Resources and the utilities, CenterPoint and Excel, and any other utilities that may be serving you. So I'll open it up to any quick questions now about kind of our process. Otherwise, we'll maybe turn it over to Nimish here and start talking about the dashboard a little bit, and I'm sure that'll open up some more questions.
Good morning, everybody. As I said, I'm myself Nimish, and I work for Ayrton. I'm based in Seattle, and I thank you so much for organizing this session today. I'm going to talk about a little bit about the dashboards, how they can help you in your facilities, what's a little bit of background, and then I'm going to demonstrate some of the stuff what we have here and how it can be useful to you guys in your facilities. So that's with that objective. Let me first of all talk about what does a dashboard do, what it can do for you. The big question here is, how can I save money on my energy bills? That's the big question here. Now, dashboard helps you around that question. It helps you provide some tools, some widgets to help you with that question. So things like, how's my building doing? First thing I want to know, what's the health of my building? Is it doing well? Is it not doing so well? Is it improving, or is it getting worse? What's happening with my building? I would like to know as a facility manager what's going around. And then I would also like to know what are the opportunities further. Where are my opportunities? Where can I save more money? Where is the opportunity? That's what a dashboard should be able to, guide a user to. And once you have implemented certain improvements, you want to see whether you are saving money or not. Is it something which is, I did this, but is it really, has it saved me money or not? So that is something you certainly would like to know. And then what about the benchmarking? I have these 15 buildings, or even we have talked about Energy Star benchmarking, What about the benchmarking? How do I know how much energy my building should consume? So those kind of questions a dashboard should help with, And employee participation. Employee participation, in my opinion, is a very important component. Typically, if you want to save any energy, let's think about in our own homes, what we're going to do. Either you change your appliances, you can improve the insulation of houses, but after that it's up to the users. So if you can motivate users, if you can engage the users, that's a big component of energy savings. Now this is something which I can talk about from my own experience within my own home. I talk to my wife, my son, he's a 5th grader. I kind of talk to them about these concepts, and what I've seen so far, my wife doesn't buy it. It doesn't matter to her. But my son, he's a 5th grader, and he has caught up to the idea of carbon footprint. He understands, whenever he uses energy, there's a equivalent carbon footprint, and you need to plant so many trees to kind of offset that. So he has kind of caught up that concept. So finding a common ground with the users is extremely critical to, improve your energy savings in the buildings. So that's one area where dashboards can be useful too. And I think as a troubleshooting tool, a dashboard has a very large role to play. Over a period of time, it's a kind of a warning tool, a kind of a tool which tells you upfront that something is going wrong. Your systems, the way they were commissioned, something is changing now, something is not right about them. So a dashboard could be very useful, and I can share some examples. Like in one of the instances, they noticed their natural gas consumption actually went up high in the summer, which was kind of counterintuitive. In winter, you expect the gas consumption to go up, and when they started looking at it, they noticed that one of the VA parks, one of the zone, was too warm, and that was driving the discharge temperature from the air handling unit. So it was overcooling, and rest of the spaces, they were first of all cooling, and they were then the reheat was kind of heating the air to maintain the temperature. So those kind of things, dashboard could be pretty useful when you see the trends going in a way which you're not expecting them to be. So as a troubleshooting tool, a dashboard has a large role to play, and there are several other instances which I can share where people have used a dashboard to doing things like identifying water leakages in time, because typically what happens if you got a water leakage somewhere, how will you know about it? It's down the line 2 months later when you get a bill from the utility. But a dashboard very quickly can generate alarms, can tell you, okay, today something has gone wrong with your water consumption, and it can warn you upfront. So those kind of things a dashboard can do. I would demonstrate a little bit of it to you today, show some of the stuff related to this. These are the kind of questions which a dashboard can actually help you with. Now on this page, you see at a very high level, it tells you what's happening with your building. Like you have electricity here, you have water here, or whatever other energy resources you have configured within your building. You come to know at a very quickly, you know what's happening. Am I going up or am I going down? This month's consumption compared to the consumption of last year, same month. So at a very, what do you call it? You see what's happening with your building at a very high level. And you, by looking at it, with the color coding, etc., you come to know there's something's wrong. My consumption have gone up or it has gone down at a very high level. That's what it tells you. Now here on this, like for example, let's say you have multiple facilities. You have facilities. I know some of you are managing multiple facilities, right,
yeah,
sir?
Or like he manages, he say 40, and
40
Bob manages
right.
that many.
Now, we all know that the resources are limited. When you want to make a decision where you should spend your money, where you have maximum opportunity in terms of getting returns out of your investment in terms of energy savings. This kind of analysis can help you. If you have those 40 buildings, you can see here that these 5 buildings are not that efficient as others are. So you can do that comparison one-to-one here. You can do a total energy comparison, you can do a per square foot basis kind of a comparison, and on a chart you can see all of the buildings laid out. And then you can see, okay, these are the probably 5 buildings, or 3 buildings, or 2 buildings which are not very efficient, and we got to do something about them. So that gives you a focus, instead of looking at all 40, maybe you focus on those 3 or those 4 or those 5. So that kind of direction a dashboard can help you with. I also talked about Energy Star benchmarking. Right now, I do not have that to demonstrate here, but we would be able to bring that in if you guys think that you want to go with this and you have the portfolio manager built up. So we might be able to bring that in here, and you'll be able to see your building versus what Energy Star tells you. So that will be a kind of a very good benchmark for you to look at and see whether your building is consuming energy as prescribed or as recommended by Energy Star, or it is something lower than that, or is it something more than that. And that gives you a very good tool, because then you can go to your management. If they ask you, okay, you cut down your energy bills, you can go back to them, no, my building is already very efficient. So that kind of analysis could be of great help.
Are you aware of the city of Minneapolis that has a new requirement for energy use disclosure? I know you're from Seattle, so maybe you're not.
No, I'm not.
But I'm wondering.
I think I know that city of Minneapolis requires at least the benchmarking based on Energy Star portfolio.
Would an Energy Star information coming through the Allerton system, do you think that would potentially be sufficient for what's being provided?
It should be, because it's based on the actual energy usage.
See, what happens is Energy Star provides the API and through which you can pull data from them. So your customers, like if you have your portfolio over there, I can tie into that and get the information from there. So I think that should be pretty accurate information.
Okay.
Yeah.
I think we plan to do incorporate one in this building too. Already a few buildings.
Now, you might see.
I think you may want to talk about sub-meter because they might be interested.
Okay. Sub-metering. Sub-metering, as well talked about, the way I look at it, it could be like, for example, you have a main building and within that you have multiple meters catering. Either it could be that you have a separate meter for lighting, you have a separate meter for plug load, or separate meter for maybe some other source of energy, or it could be that you have different zones. Now what we can do here is we can help you with a kind of a pie chart kind of analysis where you can divide your main meter into those components, into your sub-meter components, and then you can see, okay, maybe out of my 100% consumption, these are the areas which are a chunk of the thing and I want to focus on them once you're looking within the building. So that kind of analysis. Even this particular chart when you're looking at here right now, this can also help you with distribution of your energies. Like this could be a pie representing your electricity, this could be a pie representing your natural gas, this could be a pie representing your some other source of energy if you have some other that kind of energy. So even that kind of analysis you can do from here, how much of my energy, how it is distributed, that distribution you can do from here. And this can even be broken up into a dollar distribution. Let's say you want to divide your total dollars and you want to see if I'm spending $100 on my energy bills, how is the distribution, how much goes into natural gas, how much goes into electricity, how much goes into something else, you know. So even that kind of analysis can be driven from here, which can actually, if you start looking at building to building, then you would see, you know, what's happening here, why I have a different distribution. So these are the tools which an energy manager can use to dive deeper into the data and see what's going on.
It's also between the building, like if you have a surgery center and the clinic area, maybe, and they are owned by separate businesses,
okay,
they can transfer the cost, like you may have that.
Yes, even that can be done, yes, if you want to do that kind of distribution between different businesses, yes, yeah.
How is this working, tying with Envision or your new Compass software? Is it utilizing the energy log functionality and the tenant activity? Is there integration between the two softwares?
Yes.
Okay.
It ties into the database of Compass or ABS, both the databases, and from there.
So you're sharing functionality between the two systems as well?
Well, it's more. No, there's no sharing of functionality. It's just, you know, the database document.
The data is shared.
Yes. Yeah. I'll talk about little bit, you know, when you have implemented, let's say, energy conservation measure, and you want to see whether you are saving anything. Do you have the real savings on that or not? So for that we have this feature, we call it compare period. Basically it's a period over period kind of a comparison. So you can choose a time frame which is before the implementation of an energy conservation measure and a time frame which is after the energy conservation measure, and then you can see, compare them one to one and see whether the savings are really happening or not happening. And to help with the analysis, we also provide on the bottom here these overlays, like for example, you want to see heating degree hours or outside temperature, humidity, these kind of overlays are built into it. There's no data unfortunately into this. This is a dummy data what I'm demonstrating right now. It's posted on our server, but you will see a graph of outside temperature over here. Or for example, let's say heating degree hours or cooling degree hours, those kind of things. Let me see if I get some information.
I think particularly a lot of people that would humidity will be interesting one.
Yes.
Now with the new regulation.
So humidity overlay is also available, temperature overlay is available, heating degree hours, cooling degree hours, and you can also convert it to carbon footprint equivalent, if you want to. And on the right hand side, we also provide regression analysis if you guys are interested in. Now in my presentation, I haven't seen many people interested in this, but a regression analysis can be used for weather normalization. So if you want to do comparison and you want to take away the effect of weather changes and then see whether you are having a real saving or not. Like for example, last year winter was very cold. This year it may not be that very cold, but still you want to take away that impact and then want to compare. Otherwise what will happen is you implemented energy conservation measure and you might say that yes, it is not that cold, but you're still seeing the savings, and that could be just because of weather. So if you want to take away that impact, regression modeling can do that. It can take away that impact of the weather. Again, here all the energy resources are selectable: electricity, pure water, steam, natural gas, whatever you have, you can select those. You can also compare demand here if you want to do that. We also provide option of you choosing the demand here. Then these time frames are selectable. You can always change the aggregate, whether you want to see a monthly data or a daily data or hourly data. So that is something which is selectable. And also, suppose you want to plot, let's say, a past data here. Now past data could be something which is already there in the BMS system. Even that can be brought in here. So let me see if I can find something. Can't see it. I'm sorry, I'm not able to demonstrate that. But what happens here is, any past data which is recorded by the system, apart from this time range what you have chosen, can also be brought in here. So you can have basically, like for example, you're comparing 2013 with 2014, you can also bring in 2012 data for comparison.
This data can be analyzed for patients walking in, or how many surgeries done, or something like that too, right?
Well, if you want to do benchmarking on basis of number of patients walking in or the surgeries done, if that kind of benchmarking is required, it's possible to do it. The only thing for that is there has to be a way to get in that information into the system, either manually or through some automatic system which can, provide that information to our utility. So if we can get in that information, yes, it can always be populated.
Is all the information that comes into this software a backend point?
Well, actually, anything which you tie into Allerton can be picked into this. The next feature which I am demonstrating, we call it compare meter. Compare meter is again a tool for doing a drill down of the data. If an energy manager is looking into drilling down into the information, you want to compare building to buildings, you want to compare meters to meters, you want to compare floors to floors, you want to compare one building's still water consumption to the other building's still water consumption, or you want to compare similar natural gas, or a very drill down kind of analysis if you want to do. That's where it helps in. It's pretty similar to what we saw earlier. The difference here is that was between two different periods. Here you choose one period, and that period could be anything. I can choose period from 2011 to 2014, and I can choose multiple meters here. So I choose the data is dummy here, but I mean you can practically select as much range as you want here, up to 16 meters, and then compare them side by side. You can zoom in, see what's happening, zoom out, and again all those overlays are available on the bottom side. The cost overlay, carbon dioxide here, heating degree hours, cooling degree hours, temperature, humidity, and the regression modeling on the right hand side. So all of that is doable here.
I got somebody put us on hold.
We also provide you option of looking at 15-minute samples. The other features which I demonstrated so far, they allow you to do a drill down up to an hour, but here we allow you option of looking at the data at a 15 minutes interval if you want to look at that. Typically, I haven't seen many people when they do a drill down analysis, maximum people go up to 1 hour kind of level, but we provide you option of looking at 15-minute samples if you want to do that. This could be typically useful if you want to do, let's say you want to monitor the demand, and if you want to see where is the maximum demand coming from, that's where it can be useful. So 15-minute sampling, you can just choose the time frame here, whatever time frame you're looking at, and then start looking at the data. Now you can see at a time, I think only up to a week's data, because the data is too much. The amount of bars you get in a week for 15 minutes kind of interval, you have too much of information here. So at a time you can select a range of 1 week and see that information here.
Val, is the pulse meters?
Yeah,
15 minutes.
those are Excel has for 15-minute pulse meter, right?
It kind of seems
You know, must be expert on that one.
I'm gonna let Excel speak to that. I seem to recall that's the case, yeah.
That's a 15-minute, yeah.
So the benchmarking stuff is generally on KBQs per square foot per year, right? Is that the Energy Star?
Yeah, it's
So then your initial question is, how's my building doing? You know, so then you got to take that down from the year to the month, to the week, to the day to the
Right,
hour.
right.
So if you want to look at your building at this given hour, and it's July and it's design day,
Okay.
you would like to know what the model says you should be using in KBQs
Okay.
and what's actually happening at that moment.
Yeah, and they might be able to, that's where the biggest savings are going to come from, is if you can control your demand.
Right.
Like if you don't start the sterilizer for us right in the middle of or a dishwasher, which we
it's
have seen now.
not only demand, but it's just what other anomalies are happening at that moment that has the actual reading higher than what it would be modeled to be at that moment.
So you're talking about kind of benchmarking at that point of time?
Yes. Or by, so we know how much energy per hour this building should use when it's this temperature and this humidity. And if Matt's got buildings that are 30% above that hour, we want to know why. That's how my building's doing now. If it's over a week, it's too late. So, but that requires you to know.
Yeah,
from
this information.
The dashboard can tell you that it's not doing well.
Right. And we know from the trace calculation what we think the energy should be at that design moment.
Okay.
So that's another thing to superimpose to compare.
Yes, that could be a kind of a benchmarking.
Right.
That you can compare the two things and see the anomaly at that point of time.
Much more granular though than
yes.
Right.
Yes. But dashboard wouldn't tell you what's going wrong. It wouldn't tell you that this is because of this reason your consumption has gone up. It will tell you it has gone up.
Right. Which is what we want to know.
Yes. So it will tell you that there's something wrong, this is what is expected,
Yep.
and this is what you are right now at.
Yep.
And now, somebody will have to go and look at what's going wrong.
Yep. And in our experience, it's always the HVAC that's where something's wrong. The plug load, the lights, all that's predictable. But whether it's, like you said, something overheating because discharge air is too cold,
So that requires a kind of analysis.
Right.
There's something, and that's what I said. It's a kind of troubleshooting kind of tool where it will tell you, it will bring out all the anomalies. It will give those opportunities to see, okay, there's something is wrong, I need to do something about it.
Right.
Yeah, and I think that would do exactly. One of the person, if he's on the line, is at one of the facility where suddenly we saw a normal demand in January used to be around 100 kW, and suddenly it showed up 475, and he got charged and for January, February, and March. And I said, I called him. I said, were you doing electric heating or what is going on? He says, no, nothing has changed. So he found out that it was a utilities fault.
We typically find that though based on a demand charge, high demand charge, or a bad power
Right,
factor,
right.
or the resulting of the two, through our benchmarking of our utility data. Where I see value in this is we can watch, once we understand it and identify that we got a power factor problem, now we can figure out when that's occurring based on equipment operation. Is that our goal for the tool?
So you will be able to see here, okay, at this point of time you have this problem happening.
On this meter.
Yes.
Time actually, if you want to
So
to that level.
then how do you take this information and get an energy score or put it into Energy Star versus taking it from the utility benchmark? How is this beneficial? Instantaneous, I see, for identifying when and exactly more granular what's occurring, but you're dumping straight into the Energy Star portfolio from your pulse meter, or are you still taking it from its traditional benchmarking?
Well, okay, the way the API would work, it would pick up the information what is read by this tool. So whatever it's reading through those pulse meters, that's the information it would get pumped into the tool, and based upon that it will tell you then where you are. That's how it's going to work.
So it automatically uploads your energy data to Energy Star then?
It will upload automatically the data.
So it's updating it real time.
I just want to say that I do not have that module still ready. Now guys are working on that. So as far as I know, Energy Star provides you that facility. They provide you APIs to talk to them. So exact nuances, how exactly it works, what information gets passed on, what comes out, that is something still being worked out.
Sure.
But there is a way to talk to them. There is a way to get that information and then do that comparison one-to-one versus what Energy Star says and where your building is. So I think that will be pretty useful once you have that. Now, to what an extent it's going to be useful, what exactly we will do with it, once we have that, we will see.
I don't know. I think that's a small benefit compared to what you brought up, Matt. I mean, I think having an alert, if this is tracking your energy and knows what it should be based on the average temperature of a day, and all of a sudden you're 20% higher than you should be, or your standard deviation higher than you should be, it alerts you, and okay, something's going wrong with my HVAC system. Now you can track that down right away, as opposed to let that go a month or two before you see your utility bills and wonder what happened.
That could be very useful.
Yeah, I think that's maybe the point. So we got this kBTU per year number that we're trying for, but that's a year. And then if you can get it to the day, and it's a design day, how many kBTUs per day?
If it is too far different, yes.
But it's per square foot.
Yeah, per square foot.
Right, but you're drilling down, so you know what your building should burn in a day when it's design day in the summer, and then you can compare.
So is there a way to model that?
There certainly is, yes. With the trace model, we can tell you any day what it should have been.
Okay. And is there any way to
map that across a year, or every average day or whatever? Yeah.
Okay. I mean, if there's a way to get that information, and if you can create ultimately we have to bring it into our database somehow, and then that can be brought in immediately, and even the alarms can be flashed,
Right.
In a very, live databases on a very real-time basis.
Yeah, you're over what is anticipated for this condition.
Yeah. So
then you're in real time doing something.
Yes.
Well, the key will be to really on the design of our buildings, that this will play a part if we want to implement this kind of a system with our electrical, so that we can isolate mechanicals. So we're not seeing our base building energy just for lights and everything else. We want to be able to isolate our mechanical so we can see that dynamic load change.
Which is what we tries to get you to do.
Okay.
Get the light load, the plug load parceled out, and then look at HVAC.
So Champlin, you'll have that squared away for us. Sorry.
I'm not really sure, but let me just talk about them. The first thing what I'm going to talk about, we call it chiller analysis. Chiller analysis is kind of a kilowatt per ton comparison between the chillers in your facilities. So in case you have multiple chillers and you want to see what's happening with the kilowatt per ton, again now there has to be a way to read this information into the dashboard. But if you have that information, then that can be brought in here, and you can compare multiple chillers and see how their kilowatt per tons look like. Now this kind of analysis could be very useful when you want to make decisions like which chiller should be running more as a lead chiller, which chiller should be running more as a lag chiller, or you want to decide on maintenance or replacement kind of decisions. As chillers, we all know that they consume a lot of energy. A kilowatt per ton kind of analysis. Mr. Webb, do you have a lot of chillers here in this area?
We just work with this guy.
Okay. Do you have a lot of chillers here? Do you have chillers in your facilities?
We do.
Okay.
4,000 tons.
4,000 tons. Okay.
Our peak cooling is probably higher than yours. Yeah.
Oh, really?
Yeah.
Okay. So this could be pretty useful to you if you have a way to bring in this information and be able to compare your chillers across the facilities or within the facility and see how the kilowatt per tons are doing, and you can choose the durations as you want this month, this year, or whatever custom duration. That is something which you can do through this visit. I will also talk about something called energy decision tools. what I can do while this thing opens up here. We provide these pre-configured spreadsheets. We call them energy decision tools. Like for example, let's say you are doing a lighting retrofit and you want to change your lights with something else. Now, what you can do using these spreadsheets is you can put into your information to them and see whether this investment makes sense or not. A kind of financial analysis. That's number one you can do. Number two, once you've done that and you want to track it, whether you're getting the savings or not, which is required, I think, as per the IP MVP option 1 and 2. IP MVP options 1 and 2. Have you guys heard about those at all? So those options require you to kind of, first of all, they require you to kind of measure whether the savings are in place or not. These are pre-configured spreadsheets, so they ask you to enter some of the information, building data. Like for example, what are your lights, how many lights are there, how many hours do they run, and what are their wattages. And then they'll ask you what are the lights you're replacing them with, how much are their wattages. And then it will ask you things like how much is your investment. And based upon that, it will tell you that investment, what's the rate of return on that? How many years will it take to get that investment back? So IRR kind of analysis, payback period analysis, net present value analysis, kind of financial analysis which you're typically, if you go for approval to your CEO or your financial controller, he will ask you to justify why you want to do this. So that kind of analysis this spreadsheet can help you to do. And once you have done that, it can also help you to track it, whether the savings which you thought are in place or not. Now how we do it, something maybe which you guys can think about. What we do is we provide you access to all the trend logs within the Allerton systems plus all the meter data within the dashboard. That's what you provide you access, real-time access to that data. And you can apply whatever mathematical equations you want to apply on them to see whether those savings are in place or not. So, like for example, let's say you have replaced a chiller, or you have done some kind of energy conservation measure on a chiller. And now you want to isolate that and you want to see whether those savings are in place or not. Then how you can do it? Let's say either you should have a meter on chiller which measures the energy. Now we will provide you access to that meter here and you can see whether the saving is in place or not.
So Matt, back to your camp, what you really do the metering. Dave, the utility to set up the meter is very expensive. But we can get inexpensive meters.
Well, even the pulse meters aren't really that bad. I mean, just a request from the utility. But yeah, we can monitor the current on individual devices and bring it into the system as well.
So that might be all you really need, right? If you're measuring the current.
And then just assume that your base buildings stay flat and your energy fluctuations coming from the mechanicals.
Yeah.
You wouldn't be able to get real granular. That's where it'd be interesting to see mechanical load versus building base.
Yes.
But if the panels were set up properly, where you had all the VAV boxes out of a certain panel, the rooftops out of a different, then you could get what you're...
That's what I was thinking, where you like really...
Without having utilities change anything, meter-wise.
Right. Well, the pulse meters really are terrible.
The main meters.
Bring the main meters in, but maybe bring the sub panel in where that's supporting a mechanical.
So,
So looking at the time, I will cover 2-3 items quickly. Maybe I'll not show it here, I'll talk about them. The dashboard supports something called manual upload. What is manual upload is, let's say you have data, metered data, utility bills lying somewhere and you want to bring them for comparison here. You can upload that information into the system and then use it for your comparisons. Because this is talking to alerting system as we discussed about, and whatever is being monitored into alerting system, you will see that here. But let us say you have bills which are prior to that, before that, you want to bring them here and you want to see them and see what happened between 2011 and 2014 or 15. So you can upload them. That's one feature which we provide here. The second, we also provide you alarming feature here. This alarming feature is pretty simple, which can be used by the users, end users, or the facility managers. It is similar to what you do in the BMS, but the difference here is BMS has to be done by a control engineer. You will have to define the alarm, you will have to maybe commission the controller to get it, So this is different in a way that it can be done by the end user directly. So you can set up an alarm on any meter for any frequency. Let's say this meter, if my consumption goes beyond this level for an hour of duration, send me an alarm. You can set it up that way. So we provide you alarming. We also provide you reporting. You can generate reports out of it. A typical report, I think I should be able to demonstrate. I have something here. You can generate a report, something like this. Again, these are configurable by the user. They can be emailed. They'll be stored by default onto the server. You can access from there, but they can also be emailed. So reports can be generated, and if you guys think that this template doesn't suit you and you want to change the template, we can help you with that. We can do the template in a way which is the way you would like to see them. So reports can be generated. For example, we were talking about submetering now. So submetering, you don't get a bill from the utility, but if you want to see what's happening with that meter and you want to generate a report on that meter, you can do that here. I will also talk about a little bit how dashboard can be used as a engagement tool, and that has been one of the.
They can put a video into it, right? So that's what we saw.
So whatever I was showing you till now, that was more of what we call it as a power user module. Somebody like an energy manager, somebody like a facility manager, or that's a power user module we call it. We get users in that, we provide them access, for particular modules. This is more of what I'm showing right now to you is a kiosk mode. And kiosk mode, the purpose of it is to engage the users, and that's what I was talking about. That's a vital component when we talk about energy savings within the facility, because ultimately how our occupants interact with the systems, that directly influences your energy usage. So a kiosk mode dashboard goes on either a kind of a kiosk, or it can go on a television or on a screen somewhere in your facility. The purpose of it is education, number one. Number two, the purpose is PR. When an organization wants to tell its users, its visitors, how conscious they are with respect to green initiatives. It's a kind of a PR tool. So on the first page, what you're seeing here is, something, a green philosophy of the organization can go here, and some of the images, what you want to talk about, those things can go here. On this page, if you see, it's a very brief display of energy. It's not detailed as I showed in the earlier compare meter and compare period features. Here it's a kind of a brief display, a very simple display of your energy usage, a simple dial here, a simple aggregates like today, this week, this month, and energy equivalents on the right hand side. For very common people, somebody comes in and he wants to compare, see the energy, you provide them equivalents, like your energy consumption today is equivalent to so much of carbon dioxide, or carbon footprint equivalent to so much, So you show it that way, or so much of ice creams, that kind of equivalents. Again, a tool for engagement. This page is to encourage competition among the users. So you can create multiple zones within your facility. This one zone, second zone, floor versus floor, and kind of encourage people to compete with each other, see how they compare, how they are doing. That kind of process can happen here. Again, in the kiosk mode, you can have a weather visit. And on this page, one can talk about all the green initiatives which have been implemented into the building. Like, it could be anything. For example, somebody has put up a geothermal system, or somebody has a solar heat kind of a system there, or you are trying to do some kind of control strategies which are saving energy. One can talk about those. So again, it's all awareness, it's all education, it's all about building, telling your customers what the organization is doing in terms of environment, in terms of how conscious the organization is. So from that perspective, it plays a big role. It kind of engages the users, and that way it helps in terms of saving the energy. So that's the kiosk part of the dashboard. So any questions now? I mean, we can have an open discussion about how this thing can be utilized. Or yes, ma'am.
This is more of a comment that I listened to your talk and listened to everybody. And having worked on a lot of these research grants with the state, we've got a little bit of time before the contract gets finalized and we actually kick it off. And this has been a really great presentation to plant some seeds in my mind of different things we can test. One of the things that is a challenge always with these grants and contracts is that we put together a budget based on what we knew at the time. And we try to come up with some really, really good things to test out. Looking at this and seeing all the potential, that'll be one challenge, is to pick what we want to test out with this, because this is a beginning. This is something that, that we've got, we already know there's a lot of potential. We've got a very interesting tool. I can think, wow, this is going to take a little while to get everybody to get up to speed on it and what they can do. But if we can, if when you go back to your facilities and based on what you've seen today, it'd be really cool to get lots of little tests going of this dashboard. Because that's one thing is people say, does a dashboard really make a difference? And we have thought, and research is research. You guys are trying to do a before and after, before and after. Yes. And then you come up with some conclusions, and that may lead to more research. But we've got a certain box around what we're going to do with this one. And depending on your facility, and what you think today, we can do those kind of things in the first couple months. Just talk to people about what capabilities you have with your systems, what data you have, on the specific buildings, what can we do based on what Nimish has said, and then we can kind of start working out the plan and who does what, and try to figure out schedules and stuff. So this was, that's kind of things that come to mind for me. I just wanted to throw it back to you because it can be overwhelming. There's lots you can do, and picking something that works for its test site would be all we have to do. We just have to pick. We don't have to do everything that was presented today because it's
Certainly, I mean, yeah.
yeah.
You know, so even in the last couple of years, Matt, you've done a lot of initiatives. Have you got progress across the board in a lot of places with cutting energy?
Yes. Yeah, cutting energy, absolutely. We've saved close to, actually a little over $1 million based on 2010 baseline, according to our energy cap, weather normalized degree day. So we've seen significant improvements with implementing automation systems over the old pneumatics, putting enhanced strategy, control strategies, making smarter decisions on how to operate our steam boiler, or water boiler, or air handlers. Where I see potential for this over currently we run an Envision platform, and where we don't do a good job is like our sub-metering. We bring it into an energy log. It's great, it's a number. Look at it every now and then, but we don't really do anything with it. Where this would bring it more graphically out and open up potential for auto billing to tenants or people we provide. I would assume you guys have campuses where you're sending steam or hot water over to somebody, but you never really know for sure what you're sending. You might have an energy meter, and we try to keep track of that, or at least I know we have several campuses that way, where they've got an energy meter and they kind of try to keep track of it. They don't really base it on anything other than just a flat lease cost or charge for providing that service, where you could make smarter choices on this.
Oh, I wish this would have been there at MAPS, because I remember I had spent a lot of time itemizing between surgical center cost and part, and there were so many other different tenants. To separate each person's cost was an interesting challenge.
I think what you spoke to is the key is to pick, here's my base plan of a system that I'm going to get my biggest bang for my buck to implement this, and then start defining and getting more granular with how I can use it for, PR, for, sub-metering information or sharing floor to floor of what your data is. Because if you start getting that granular, you need to be able to prove the big win, I guess, on each building. So to me, I think you got to kind of figure out what's our big win on how we can utilize this to prove that big win, and then get more granular as you learn what you can do with it, I guess, and get buy-in from your company.
So you don't use the sub-meter data yet to troubleshoot, like, whoa, somebody took that setback off on that, you should run it.
We catch it on we benchmark through a software called Energy Cap, but it's based solely off of the bill. So we catch it months after it occurs. Where we lose or miss out on is, shoot, this quarter we would, in the toilet on this one. Well, we got a lot of hunches, we got a lot of guesses, but with this we would be able to see real-time data and catch those problems instead of going on a hunch and trying to witch hunt where the problem is. We should be able to identify tighter, I guess.
But is the problem HVAC usually?
Yes.
Yeah. So if we're talking about where it's HVAC, that's where all the variable is, and metering the components of it, whether it's pumps, rooftop units, electric reads, or boilers, whatever. If you had all those major components isolated,
I think that would help.
And then have something as a baseline that's expected.
Right. And that's
particularly, I think we are talking about medical clinics here, and the biggest one I have seen as far as is the outside air, kills air, particularly with humidity, and that's what exactly we found with working with on ambulatory surgery center. This big drop is as soon as you cut the outside, because require ventilation for operating rooms is 5, right? 5 air changes according to our Department of Health requirements. So
So that, and then maybe
Then,
Talking fresh air.
fresh air.
Yeah, fresh air.
And then maybe too low a discharge airs, which
Right.
is causing,
And then over reheating it.
yeah.
That's where we've seen our biggest win on energy savings is not taking it way down and warming them back up,
Right.
trying to look at more of an average playing field. And I think we could utilize this as a tool to find that sweet spot better and identify where when we see these huge demand charge, when is that occurring?
Yeah.
More so than what we can tell off of a traditional benchmark.
And
So how do you measure the demand as in today? I mean, what's the
it's, the
based off
way
the bill,
it accumulates the energy from every 15 minutes, and it skips a 5-minute period, like 15 minutes.
So you get a
it
pulse
starts-
every 15 minutes?
Yeah. The total get the pulse, and then from pulse you let's say it starts at 12 o'clock, it will go up to 12:15.
Okay.
And what's the amount of energy used in that time frame? Then it will start the next phase is at 12:05.
Okay.
It's 5 minutes, and then it will go to 12:20.
Okay.
And then it will compare. Whichever is the higher one, they will keep it. And that will be the one which will be charged for 15-minute period.
Okay.
So,
Yeah, we're gonna have to wrap up.
right.
Okay.
Well.
Well, yes, thank you everybody for organizing this session, and I appreciate you all coming over here and spending the time with us today. Gilbert, again, I say thank you to you all too for calling me here for this presentation, and I would share some of the information with Gilbert on this. If you guys have more questions, you can always ask us, and we will.
Why don't I send you?
those.
You can send it to, if you can. Anybody needs this presentation copy?
I mean,
That would be great. I
If you
can.
guys
we can
need
send.
anything from me, I
Yeah.
would be able to share. Actually, whatever I demonstrated to you earlier, that's hosted on our internal server. You can access that if you want to do that. So that is possible. Once again, thank you so much. I think our time is up
Yeah.
here. Yes.
Thank you.